So in looking at this reaction, we know based on the conditions, strong base, this is likely to be an elimination reaction. In addition, the solvent is a polar aprotic solvent. So that means we're dealing with an E2 elimination. And so normally in a situation like this, we would start by looking at our best leaving group, which are the iodines. However, you may recall that when we were in a cyclohexane ring, it's not always that simple or straightforward, because our leaving group and our hydrogen that we're removing have to be anti-periplanar to each other. So before we can determine what the product for this reaction is, we need to redraw this structure in its chair conformation. So the tert-butyl group is pointing up. We know that tert-butyl has to be in an equatorial position. From here, we have a bromine down. That's also equatorial. An iodine up is equatorial. Fluorine up is axial. Iodine up, equatorial. And bromine down is equatorial. Now remember, in order to adopt that anti-periplanar conformation in a cyclohexane ring, that means it needs to be in an axial position. The only substituent in an axial position is this fluorine. And unfortunately, fluorine is a very bad leaving group. Since it's a bad leaving group, we're not likely to be able to get any elimination to take place. Now we know that substitution can compete, but substitution isn't likely to be favorable either in this case, because potassium T-butoxide is a very large base. So the likely result is that this reaction will just not work at all.